This is our single line diagram of 11 kV from ZAMAN Park feeder, which we have used in our project for analysis. Here we have 8 transformers of 25 kV, 8 transformers of 50 kVA, 26 transformers of 100 kVA, 38 transformers for 200 kVA rating, 7 for 400 and 5 for 630 kVA rating. The conductors we have used are panther, dog, rabbit, and the length of line is 500 mcm, 4 AWG and 2 AWG. Here our starting node here is 0 to 1 at the bottom, at the left bottom, and it, the stream goes on and the string goes on till 112 nodes. And this is the diagram we've used in our bifurcation and reconducting processes, which will be shown later on in the video. And this diagram is our main initial diagram for which we have used in the project.
This is our These are our entries of 11 kV Zaman Park feeder, where we have 112 nodes. As you can see here, we are finishing at 112. Okay, each each node is having its conductor code and its kVA. The kVA represents the transformer, the power of the transformer attached to that node. Now, for reconducting, okay, first we will proceed to the analysis to check at which nodes do we need to change the conductor to improve its losses. So current in amperes we will keep it at 100, bus voltage will be 11 kV, power factor and load factor will be kept at 80%. Now we will study with growth at 13% for a time period of 5 years. Since uh, since we do not need any new capacitors to be installed, so we will select the no option here. Now it's performing the load flow analysis to display the results. As we can see that at node 7 to node 8 the conductor is rabbit and losses are 0.803. So to change the conductor here, in order to reduce the losses, we will go back at the reconductoring option. From here we will enter from node 7 to node 8, and our new conductor code will be OSP, representing osprey. Since we are carrying no more reconductoring, we will select the no option. We'll proceed for the analysis again. All values will be kept same as before. We will study with growth, same 13% rate for the time period of 5 years. It's performing its load flow analysis, and now we'll display the results. So here we can see that from node 7 to node 8, first it was drab, conductor code was drab, and losses were 0.803. Now we have changed it to OSP. The conductor code is now changed to OSP, and the losses are reduced from 0.803 to 0.150. From here we can see that initially our losses were 2,38,912, and after reconductoring it is reduced to 2,24,007, and a benefit of 6%. So for this we will carry out more reconductoring, respectively at node 8 to node 9. We will change our conductor code from grab to OSP at node 15 to 16. Also, we'll change our conductor code from grab to OSP at 22 and 23. Again, we will do the same. We'll carry out the same process from node 800. From node 87 to 802. We will change our conductor code from dog to double dog, represented by DDG. And at node 108 to 109, we will carry out the same process. Now, after that, carrying out those processes, we will after carrying out those processes, we will see that we have changed the conductor codes at node 11 to 15. First it was RAB, and the losses were 0.152. After changing it to OSP, the losses have gone down to 0.028, and respectively at node 15 to 16, we have reduced the losses from 0.174 to 0.033, and from node 16 to 17, from RAB we have converted to OSP, and the losses have reduced from 0.139 to 0.026. At node 87 to 102, our conductor code was dog, and losses were 0.649, and we have replaced it with double dog, and losses have reduced to 0.325. At node 108 to 109, again we have done the same procedure. We have replaced dog with double dog, and our losses have reduced from 0.211 to 0.105.
Now we will start with bifurcation. Bifurcation is basically a division of something into two branches or parts. Here we will divide our nodes into two parts to reduce the losses in those lines. Now, as we can see that from node 69 to 72, our losses are 1.970, and in total, our losses are 2,24,007. To reduce these losses, we will perform bifurcation at node 69 to node 72. To perform bifurcation, we will modify our segment data. From here, we will go to node 69 to 72. Here we will edit our data and connect node 72 with from node 1. And now we will observe our losses. At first, those were 2,24,007. Now we will check how much reduced are those losses now. Now we will proceed for analysis. Here we will again enter the current in amperes at 100 value. Bus voltage will remain at 11 kV. Power and load factor will remain also at 80%. We will study with growth of at 13% for 5 years. Now it will perform load flow analysis, and we shall be seeing the results soon. Now we will see the displayed results. Now from here we can see that bifurcation is done from node 1 to node 72, and our losses at first were 2,24,007, and they have been reduced down to 74,058, a benefit of 17%.